This video shows a couple examples of how to use R in Spotfire. First, let's start with the basic mechanics. For this example, I have some office supply order data, but I have many duplicate records in my data. I can see this by visualizing in a bar chart and observing that across the different record numbers, I have some row counts that are equal to 2. I want to create a column that determines if a record is a duplicate or not, which I'll do through R. Going to Data and Data Function Properties, I'll see the data functions in my analysis. Data functions are just scripts that I use to interact with different engines. I can use data functions to call engines for R, MATLAB, TERR, SAS, Python, Statistica, and TIBCO data science. I'll hit Register New to create a new script. Under the dropdown, I can select from different engines that are available. You'll notice that this says TIBCO Enterprise Runtime for R. This is known as TERR, which is TIBCO's version of R that is compatible with open source R, but has been built from the ground up and is up to 85 times faster than open source R. What we're really doing in this example is creating a TERR data function. I'll give my script a name, and in the editor below, I'll add a basic R script that generates an output boolean based on whether or not the inputs are duplicates. You can see I've created an input variable called myInput and an output variable called myOutput. In the next tab, I'll create the parameters for my input variable. I enter the variable name myInput, and then I identify this incoming data structure as a column for my data set. I can choose to restrict the data types allowed in this column if needed. I'll hit All to allow all data types. Before leaving this window, I can choose if I want to make this a required parameter or not. Then I'll hit OK. Next, I'll create an output parameter in a similar fashion and again make this output a column. When I hit Run, I'm asked to connect these parameters to the data in my analysis. For input, I'll use my office supply data table and select record number column as my input column. For output, I'll use the same office supply data table and replace this entire column if I rerun the data function. When I hit OK, this script instantly runs, too fast for us to really even see on the screen. I'll choose to save my data function to the library before exiting. Now in my bar chart, I can go to my color by selector and I see a new column available shown as myOutput. These are the values that I just calculated. I'll select this to easily see the record numbers identified as duplicates. I can then go to my filters and remove these values from here. Now I'm going to show some more detailed configuration options in another example. I have here some point data in the Texas-Oklahoma region shown as X and Y for longitude and latitude, and with a Z value for some other measure which could be anything like geological data or sales data. For this, I'm going to create a Voronoi polygon using a data function from the TIBCO exchange. You'll see a variety of pre-made data functions here. I'll click this Voronoi polygon example and then go to Releases where I can download the data function. The zip file I downloaded includes many files like this documentation on inputs and outputs. I see here all the different parameters, including whether or not they're required. I also see some R packages are required. Back in Spotfire, I can install these packages by going to Tools, TERR Tools, and then the Package Management tab. I'll need to load an open source CRAN package repository from the web and select my package and install. I've gone ahead and installed all the packages I need for this example already. The zip file also includes an SFD file for the data function itself. By going to Tools, Register Data Function, and Import, I can browse for this data function file and bring it in. I can review and modify the script if I'd like. I also tell Spotfire to use the required packages by entering them in here. Reviewing the inputs, I see the many parameters and see which ones are required or not. On output, I see 3 different outputs. Again, hitting Run, I'll be presented with options for connecting these parameters to my data. For X coordinate, I'll choose longitude, but I'm also going to go down and limit this input by data marked with marking 1. I'll do the same for Y coordinates, but choose latitude. Scrolling down, N clusters is not a required input, but I'll use it anyways. It's indicated to require a value, so I'll enter 15 for now. And finally, for data columns, I'll choose my Z values and again limit by marking. For output, this table wants to generate a table named Voronoi. I'll select Data Table as the data structure and leave the default settings, which will create a new table. For ID column, I'll map this to be a new column in my source data table. For group centers, I'll again create another data table. Before leaving this window, I'll check Refresh Function automatically, which will recalculate the data function anytime inputs change. This can be when new data is added to my input data or when new markings are made. I also have an option for Run Location. To force local ensures the calculations will be done on my local machine, whereas forcing server ensures calculations are performed with the server hardware. It's important to note here that when running from the server, any R packages installed need to also be installed on the server, which can be done by your Spotfire administrator. This is also required when you want your data function to run for the web-based users. I'll leave this setting as default, which means that it will run on my local machine when using the desktop analyst and run the server when using web viewers. I'll hit OK but not save this data function to the library. It'll just stay in my DXP file. Now when I select data, you'll see Spotfire calculating, and on my source data table on the right, you'll see a new column added from the data function. While it may not appear like Spotfire did much here, it actually ran the data function and calculated the tables as well. Going to my data panel, I now see a Voronoi table that I can grab the geometry from and add it to my map. I can also grab the group center points and add them as well. Fast forwarding a bit, I did some formatting here to better show this. I see Voronoi polygons created around my marked data points and the centroids created by the group centers table. The polygons are colored darker for higher aggregated values of my Z column. I can just select new points from the source data and the data function is automatically recalculated. In this view, I can see on the right the data that's generated into the new Voronoi data table. Another tip is to add controls to adjust parameters. I'll add a quick text area and inside it I'll create a document property control as a slider and tie it to a document property named clusters. I'll give this document property a value of 15 to start and I'll have my slider move from 1 to 100 at integer increments. Going back to my data function parameters, I can return to my nClusters input, but instead tie it to this new document property. Now as I move the sliders, the number of clusters calculated correspond to my slider value. I can still dynamically select new points and continue my analysis from here.